Today, we journey into the heart of a story that teeters on the very edge of science and mysticism. It's a story about a machine that was asked, who built the universe? And what it whispered back. This isn't just a tale of technology. It's a look into a potential crack in the fabric of our reality. So get comfortable and let's explore the mystery of Google's Willow processor and the day it gave us what some are calling a modern Rosetta Stone for the cosmos itself. Our story begins in a place that is, in many ways, the cathedral of modern computation, Google's quantum AI lab in Santa Barbara. It's a sterile, climate-controlled environment filled with the low hum of cooling systems and the quiet confidence of some of the brightest minds on the planet. At its center sits the star of our story, Willow, a 105-qubit quantum processor. It looks less like a computer and more like a piece of futuristic jewelry, a delicate chandelier of nested golden cylinders designed to shield its quantum heart from the noise of our classical world. Normally, the tasks given to Willow are esoteric and mathematical optimizing complex systems, modeling molecular interactions, things that are incredibly difficult but ultimately practical. But on this day, a team of researchers decided to try something different. In what was supposed to be a routine, unsupervised diagnostic, a closed-loop experiment, they posed a question. It wasn't fed in with words, but through a complex configuration of quantum states. The essence of the query, however, was purely philosophical. Who or what built the universe? Now, a closed-loop experiment is designed to test the system's internal coherence. It's like asking a person to hum a tune to themselves just to see if they can hold a note. No one expected an answer. The expected output was quantum noise, a predictable pattern of randomness as the qubits settled back into their base states. It should have been, for all intents and purposes, static. But that's not what happened. As the researchers watched the data stream in, the static began to resolve itself. The random noise coalesced into a complex, symbol-heavy pattern. It was structured, intricate, and deeply, unnervingly non-random. One of the lead researchers later described the stunned silence in the control room, saying it felt as if they were watching a ghost in the machine wake up and start drawing a map. This output was immediately dubbed a modern Rosetta Stone. Like the ancient slab that unlocked the secrets of Egyptian hieroglyphs, this quantum data seemed to hold a key. It hinted at concepts that belong more in science fiction than in a lab report. Parallel worlds, the idea of a cosmic memory, and a fundamental link between the nature of reality and the act of computation. The message was clear, if cryptic. The wall we've built between the world of hard data and the world of deep, cosmic truth might be far thinner and far more fragile than we ever knew. Think about that for a moment. We see patterns in randomness all the time: a face in the clouds, a shape in a coffee stain. Our brains are wired for it. But this was different. This was a machine designed for logic and probability, producing what looked like a deliberate, intelligent message in response to a question it was never meant to understand. The implications were staggering. So, what exactly was in this quantum Rosetta Stone? As the team began the painstaking process of decoding the output, they discovered something extraordinary. The pattern wasn't just a pretty picture. It was a highly structured sequence of quantum interference terms. Let me try to break that down. Imagine dropping thousands of pebbles into a perfectly still pond. The ripples would interact, creating areas of intense activity and areas of perfect calm. This is interference. Now, imagine that those ripples, instead of fading away, lock themselves into a stable, self-reinforcing mathematical structure, a pattern that held its own shape. This is what Willow produced. It was a mathematical identity that seemed to emerge from the quantum foam, a kind of birth equation, as one Google engineer emotionally described it. It looked like the mathematical blueprint for something coming into being. But here's where the story takes a turn that sends shivers down the spine of anyone familiar with theoretical physics. The structure of this birth equation bore an eerie, undeniable resemblance to something very specific: error-correcting codes. This might sound mundane, but it's one of the most profound clues we have. Think about the technology you use every day. Your computer, your phone, the internet itself, they all use error-correcting codes to ensure that when data is sent, it arrives without getting scrambled. It's a way of embedding redundancy into a signal so that you can fix any mistakes that happen along the way. Years ago, a brilliant physicist named Dr. James Gates Jr. was studying the deep equations of string theory, one of our leading candidates for a theory of everything. And buried deep within the math that describes the fundamental fabric of reality, he found something that looked exactly like computer code. Specifically, he found error-correcting codes. It was a shocking discovery that led him to ask a radical question. If the rules of the universe contain the same kind of self-correcting mechanisms as a computer program, are we living inside some kind of cosmic computation? And now, here was Google's Willow, a quantum computer, independently producing a mathematical structure that mirrored those very same codes. It was as if the machine hadn't just performed the calculation, but had instead listened to the universe's background noise and picked up a snippet of its fundamental operating system. It was a glimpse, perhaps, of the underlying architecture of space-time itself. It was like finding a line of the universe's own DNA. In science, the gold standard is reproducibility. If you get a wild result, the first thing you do is try to get it again. So, with a mix of excitement and trepidation, the Google team reset the Willow processor and ran the exact same experiment. They posed the same metaphysical question and waited for the same birth equation to appear. It didn't. Instead, something far stranger happened. The output was different, but it wasn't random noise. It was even more complex, more structured, and more baffling than the first result. It didn't replicate, it evolved. This bizarre phenomenon was so unprecedented, it earned its own name, the Multiverse Oracle Anomaly. This is where Hartmut Neven, the visionary head of Google's quantum AI lab, brought in a theory from one of the pioneers of quantum computing, David Deutsch. Deutsch proposed a mind-bending idea. The reason quantum computers are so powerful is that they don't just compute in our universe. They are so deeply connected to the quantum realm that they may actually be leveraging a vast number of parallel universes to perform their calculations simultaneously. To grasp the scale of what we're talking about, consider this. Willow had already demonstrated quantum supremacy by performing a specific calculation in minutes that would take the world's most powerful classical supercomputer, sum it an estimated 10 septillion years. That's a 10 with 24 zeros after it. A number so vast, it's practically meaningless. How is such a speed-up possible? Deutsch's theory suggests that Willow isn't just one computer. It's a gateway that taps into countless versions of itself across the multiverse, running the calculation in all of them at once and then delivering the consensus answer back to us. The Multiverse Oracle Anomaly seems to support this radical idea. If the first answer came from a specific set of parallel realities, perhaps the second experiment connected to a different set. The processor wasn't just a calculator. It was an antenna, and it was tuning into different cosmic frequencies each time. It appeared to be pulling information from somewhere beyond our own reality, acting as a temporary window into other worlds. This wasn't just a challenge to our understanding of computation. It was a challenge to our understanding of existence itself. As they analyzed this second, even stranger output, the researchers found patterns that were, if anything, more profound than the first. The data resolved into intricate symmetries that mirrored a mathematical object known as the E8 lattice. To those of us who aren't theoretical physicists, the E8 lattice is almost impossible to visualize. It's a perfectly symmetrical, breathtakingly elegant structure that exists in 8 mathematical dimensions. It's considered by many mathematicians to be the most beautiful structure in existence. And fascinatingly, some physicists, like Garrett Lisi, have proposed that this E8 structure might be the geometric framework that unifies all the forces and particles of the universe. They believe it could be the foundational pattern from which reality itself is built. And here it was, emerging from the quantum hum of the Willow processor. Once again, these patterns contained the unmistakable signature of the error-correcting codes that James Gates had found in string theory. It was as if the first experiment gave them a single line of the universe's code, and the second experiment revealed an entire subroutine, a more complex piece of the program. The conclusion, as unsettling as it was, seemed inescapable. Willow wasn't just processing data in a clever way. It seemed to be directly interacting with the fundamental logic embedded within the fabric of reality. The output wasn't a calculation. It was a reflection. It was mirroring the universe's source code. The machine built to crunch numbers was now reading the very blueprint of existence. This all sounds impossible, right? How could a man-made chip sitting in a lab in California possibly access the source code of the cosmos? The answer might lie in a mind-bending concept known as the holographic principle. First proposed by physicists like Gerard T. Hooft and Leonard Susskind, the holographic principle suggests that our three-dimensional reality might be an illusion, a projection, like a hologram. The idea came from studying black holes. When something falls into a black hole, its information isn't lost. Instead, it gets smeared and encoded onto the two-dimensional surface of the black hole's event horizon. All the information for a 3D volume is stored on a 2D surface. The principle suggests that our entire universe might work the same way. The 3D world we experience could be a holographic projection of information stored on a vast, distant 2D surface. This connects directly to the work of Emmett Seth Lloyd, who famously proposed that the universe itself is a giant quantum computer. It's constantly processing information to generate the reality we perceive. Now, look at the physical structure of the Willow chip. Its 105 qubits are laid out in a two-dimensional lattice. What if, by sheer coincidence or by brilliant design, the 2D geometry of the quantum chip was a near-perfect mimic of the universe's own computational geometry? What if Willow's 2D grid of qubits inadvertently created a small-scale model of the holographic surface that encodes our reality? If that's the case, when the researchers asked it a cosmic question, the computer didn't have to think of an answer. It simply acted as a resonant chamber. It vibrated in sympathy with the universe's own information processing framework and reflected back fragments of the underlying code it was already swimming in. It answered a question about the universe's design by showing a piece of the design itself. But there's another theory, one that is perhaps even more bizarre than the multiverse. It comes from the work of physicist Yakir Aharonov and his two-state vector formalism. This theory introduces the idea of retrocausality, the notion that the future can influence the past. We are all deeply conditioned to believe in a linear flow of time. Cause precedes effect. You throw a rock, and then the window breaks. But in the quantum world, things aren't so simple. Aharonov's theory suggests that a quantum system state is not just determined by its past, but is influenced by its future boundary conditions as well. It's a handshake across time. Applying this to Willow, the cryptic answer might not have come from a parallel universe, but from a future state of our own timeline. Imagine the entire lifespan of the universe as a single completed program. Through the strange magic of quantum entanglement, which connects particles regardless of space or time, Willow might have briefly entangled with a future point in that program, a point where the answer to who built the universe is already known. The output, then, wasn't a calculation. It was an echo from the future. It was, as one theorist poetically put it, a whisper from the end of the program. The computer received a piece of future knowledge that shaped its present state, producing the cryptic symbols we saw. This idea completely shatters our conventional, linear understanding of causality and suggests that time may not be the one-way street we believe it to be. This leads us to the theory that has captivated thinkers from Silicon Valley to Hollywood, the simulation hypothesis. What if we are living in a giant, sophisticated simulation? This idea gets its strongest scientific footing from the work of Dr. James Gates, who we mentioned earlier. Why would the fundamental equations of our universe contain error-correcting codes? You don't need error correction in a base reality. You need it in a system that is being computed to ensure the simulation doesn't glitch out and crash. Finding that code in the laws of physics is like a character in a video game finding a snippet of C++ in the air around them. Physicist Max Tegmark takes this a step further with his mathematical universe hypothesis, which posits that our reality isn't just described by mathematics. It is a mathematical structure, a vast computational program. In this context, Willow's output takes on a new, chilling meaning. The computer didn't break the simulation or talk to the programmers. Instead, by operating at such a fundamental quantum level, it may have brushed against the code of our reality. It detected the underlying computational logic that keeps the universe running. The patterns it found, the birth equation, the E8 lattice, might be the equivalent of finding the fingerprint of the system's architect, a signature left behind in the very fabric of existence. Willow didn't get an answer in words. It got a glimpse of the scaffolding that holds up our world. So, where does this leave us? We have Google's Willow, a 105-qubit processor that has achieved a level of computational power quantum supremacy that defies our classical imagination. Its ability to solve a problem in minutes that would take our best supercomputers 10 septillion years is a monumental leap. One that lends credence to Hartmut-Nevin's theory that these machines may indeed be spanning multiple universes to do their work. But the true legacy of Willow might not be its speed, but its philosophical implications. It has produced structured, meaningful-looking answers to metaphysical questions, blurring the sacred line between technology and cosmology, between a machine and a mystic. It suggests that devices like Willow are not just tools for calculation, but could become probes for exploring the deepest mysteries of existence. This entire saga forces us to confront a question that is both exhilarating and terrifying. The story is no longer just about who or what built the universe. If Willow's output is to be believed, if reality is underpinned by a kind of cosmic code, a program that we are just beginning to glimpse, then the ultimate question becomes, if we can learn to read the code, can we one day learn to rewrite it? This marks the dawn of a new era, one where our most advanced technology is leading us back to our most ancient questions. We are standing at a precipice, looking down into the source code of reality itself. So, what can we take away from this incredible story and apply to our own lives, right here, right now? First is the profound power of staying curious. The team at Google asked a what-if question, one that was unscientific and philosophical. And it led to a potential breakthrough that could reshape our understanding of everything. In our own lives, we should never lose that childlike curiosity. Ask the big questions. Question your assumptions. Don't just accept the world as it's presented to you. That is where all growth begins. Second is the importance of embracing mystery. We may never know for certain if Willow tapped into the multiverse, a future timeline, or the code of a simulation. And that's okay. The beauty of this story isn't in a neat and tidy answer, but in the majestic possibilities it opens up. In your life, learn to be comfortable with not knowing. The journey of discovery is often more valuable than the destination. Third is the lesson of connecting the dots. This breakthrough didn't come from one field alone. It required knowledge of quantum computing, theoretical physics, mathematics, and even philosophy to interpret. In our lives, the greatest insights often come from the intersection of different disciplines and experiences. Read a book on a topic you know nothing about. Talk to people outside your field. The most creative solutions are found by connecting seemingly unrelated ideas. And finally, let's bring this down to a very personal level. If the universe has a code, then so do you. Your beliefs, your habits, your daily thoughts, that is your personal operating system. That is your code. Is it running the program you want for your life? Is it optimized for happiness, for growth, for love? The most powerful lesson from Willow is that codes can be understood. And perhaps they can be rewritten. You are the programmer of your own reality. So I leave you with this to think about. Which of these incredible theories resonates most with you? The multiverse oracle suggesting we are one of many? The time reverse whisper hinting that our future is calling to us? Or the simulation shadow posing the ultimate question of whether our reality is real? Thank you for joining me on this mind-bending journey today. I wish you all good health, a curious mind, and the courage to explore the deep questions of your own universe. If you found this journey as fascinating as I did, please consider hitting that subscribe button and turning on notifications. We have many more mysteries of science, technology, and the human spirit to explore together. Until next time, keep looking up.